welcome to my channel. Today we continue with our study on integral calculus, and we're looking at how to change limits during integration. And you see, changing limits makes our work easier, and that is why it's necessary for us to learn on how to change these limits. So let's look at examples. And the first example is this, that we are given these questions to evaluate. We've done these questions in our earlier video, and we are repeating them this time, trying to change limits and see that we get the same results. So we are given this integral, the integral of 10x minus 2 cubed dx, and the limits are 1 to 3. So these are the limits for x. We shall want to change them to other limits and see how that works. Now let's look at the workings. Now this is the question I'm given, that you are supposed to integrate 10x minus 2 cubed dx, and the limits are from 1 to 3. So we just do the same thing we did last time. We let this inside the bracket be u. That's what I've written, that let u be 10x minus 2. And what happens after this is that you differentiate. When you differentiate the left side, you get it u, and the right side, you get it 10 dx. So as we've been doing before, we make dx the subject, and when you make dx the subject, what you get is dx is the same as du over 10. That is, you divide both sides by 10. So that's what we did, and this is what I got. And now what happens from there? Once you've gotten dx, you come here and substitute. You come here and substitute, and that's what we did. But before substitute, let's change the limits. The limits that we are given are for x. We've not been given the limits for u, so we want to change this limit so that they are for u. And we've been told that x, the limits x is equals to 1. We have the limits x equals to 1, and you also have the limits x is equals to 3. So what is u when x is 1? And so we are just using this equation here. What is u when x is 1? So when x is 1, our u will be 10 times x, but x is 1, and then minus 2, and this is 8. So this is our new lower limit. What about the upper limit when x is 3? When x is 3, and again using this equation, we have u equals 10x, but x is 3, then minus 2, and this gives you 28. So this is our new upper limit. Now I want to substitute all this with the new limits, and this one with the u, and this with the equivalent of dx, which we have here, and then we do the integration. So what does our integration become? Our integration, therefore, this was our original integration. X, the lower limit was x equals to 1, the upper limit was x equals to 3, 10x minus 2 cubed dx. So we now just substitute. Our new lower limit is 8, and our new upper limit is 28. But instead of this, we call this one u. That's what we call u. So I write u cubed, and then instead of dx, I write du over 10. That's what we got. Now let's do the integration. Let me clear this first. So we're just doing the integration now. Remember the new limits, and remember that we are using substitution method here. And and instead of this we've written u, it's u cubed dx. Instead of dx we've written du over 10. And you're already familiar with this type of substitution because we've had several videos on this type of integration. Now, taking the constant out of the bracket, the constant is 1 over 10. 1 over 10, the integral from a to 28 of u cubed du. Now, integrating, as we've always done, we add 1 to the power and divide by the new power. So when I add 1 to 4, no, to 3, I get 4. So it will be u, this will be the same as 1 out of 10 u raised to 4 over the new power, which is 4. Now, since this is a definite integral, there's no need of adding constant of integration. So we are doing this from 8 to 28. And that's what I have here. Because the denominator is 40 and 1 over 40, u raised to 4 from 8 to 28. So we just put the upper limit, 1 out of 40, 28 is the upper limit raised to 4, so u becomes 28, and the next one, u is the lower limit, which is 8 raised to 4. So when you do this with your calculator, you get this as the answer. So this is what we've done by changing limits. So you can see that we changed the limits here and it has made our work shorter. Otherwise, if you would not have changed the limits, you recall that we would have reached at this point and substituted u, and our u was this. We would have substituted back the x. If you wanted to use the limits for x that were given at the start of the question, then you would have replaced back your u here, replace it back and raise it to 4 so that you use the earlier limits. Now let's look at another example just to make the concept of changing limits easier for us. So this is the question. This time we are doing we are integrating this trigonometric function cos 5x. Now you can begin by taking this constant outside the bracket. There's no problem with that. And you remember that for us to integrate this, we have to let this 5x be u. So you say let u be 5x. And then as we've been doing, you differentiate on both sides. The left side will be du and the right side will be 5 dx. And then if you made dx the subject, you would have du out of 5. So this we will substitute here. We'll substitute there. And then this u will substitute here. And then we need to change our limits. The limits given to us are for x, but we're now using u. We'll be using u, that means you must have limits for u. So we just come back to this equation and it will assist us to change the limits. We say when x is 0, what will be u? So when x is 0, u will be 5 times 0, which is 0. What about when x is pi over 2? When x is pi over 2, then u will be 5 times pi over 2, which is just 5 pi over 2. 5 pi over 2. And that is what you see, that my new limits, the lower limit will be 0 and the upper limit will be 5 pi over 2. We're now ready to substitute. So we come back and now do the question. So instead of all the limits, let's write the new limits, which are 0 to 5 pi over 2. And then there's a 7 cos instead of 5x, we call 5x to be u, and instead of this dx, we have du over 5, du over 5. So this is, it is here, we are here, that's what I got, that's how I got this part. So at this point, we now take out the constants, and the constants are 7 over 5. So we have 7 over 5, the integral of cos u, the integral of cos u, and our upper limit is 5 pi over 2, the lower limit is 0. So let's just expand that. Let's do that. So we need to integrate this cos u, and we know that cos u, integrating it will give you sin u. Sin u. So the integral of this is sin u. So what I get here is 7 out of 5 sin u. There is no need of adding the constant integration because we are dealing with a definite integral. So this will be 5 pi out of 2 as the upper limit. Now just put the upper limit and then put the lower limit and subtract the two answers. So what I have is 7 out of 5 sin u, but u is the upper limit now, which is 5 pi out of 2, then minus sin u. U now is the lower limit, which is 0. And when you do this with your calculator, you get 1.4 as the answer. You get 1.4 as the answer. Now let's look at another example. As usual, we do several examples just to make our concepts easier. Now we want to integrate this 7s out of the square root of 13s squared minus 2, and the limits are 4 to 1. So we need to change these limits, and we need to call whatever is under the root as call it u. So whatever is under the root, call it u. So what is under the root is 13s squared minus 2. And differentiate both sides to get du equals to 26s ds. Now make ds the subject. Make ds the subject by dividing both sides by 26s. So you get du out of 26s. Now, what follows is to change the limits. The limits given to us are for s, but we want limits for u. So we ask ourselves, when s is 4, what will be u? So when s is 4, it was s not x. When s is 4, then u will be 13 times 4 square minus 2. 13 times 4 square minus 2, which is 206. What about the upper limit? When s is 1, so when s is 1, just substitute 1 here, and you have 13 times 1 square minus 2, which is 11, as the upper limit. From there, what follows is to do the integration. So what we have is that the lower limit is 206, the upper limit is 11, and what we integrating is 7s out of the root of u. We call it u. We call this under the root, we call it u, the root of u. ds, we call it du over 26s, du out of 26s. So you notice that this s and this one will cancel out. And so what you, when you take the constants outside the integral sign, our constant are 7 out of 26, And inside the integral, we would have u raised to a half du. U raised to negative a half du. And our limits are 206 to 11. So let's just do that. So this is what I wrote here, the same thing. Now at this point, let's integrate u raised to a half. And to integrate u raised to a half, remember that we're adding 1 to the power and dividing by the new power. So what I have is u raised to a half, add 1 to that, and divide by the new power, which is a half plus 1. Notice that negative half plus 1 is just a half. It's just a half. And then divided by that half is the same as getting 2 raised to 2 times u raised to half. 2 times u raised to half. So that is why when I multiply that 2 times u raised to half by this constant, which is 7 over 26, what I come up with is 7 u raised to half out of 13. And that's what I have. And the limits are 206 to 11. So what remains is just to insert the limits in this. Just insert the limits now. So you have you insert the upper limit. The upper limit is 11 raised to a half, which is the same as getting the square root, and then minus. Now insert the upper limit, which is 206 raised to a half, which is the same as square root. And that's what you see here. And when you do that, that can be done with a calculator. When you do with your calculator, what you get is negative 5.9425. If the answer is put to 4 decimal places, of course there are several decimals here, so I've decided to put to 4 decimal places. Now let's look at this other example again, just to make our work easier. We want to evaluate this, so I can see you already are familiar with the concept now, that we're letting whatever is under the root to be u. So we let whatever is under the root to be u, 7x cubed plus 2, then differentiate on both sides to get du equals to 21x squared dx, and make the x the subject. Make the x the subject by dividing by this on both sides. We would have du out of 21x squared. Now after that, just change your limits. This is u. So you ask yourself, when x is 0, what will be u? So when x is 0, what will be u? So just put 0 here. 0 cubed times 7 will be 0 plus 2. So the lower limit will be 2. Because if you put 0 here, it will be 7 times 0 cubed plus 2, which is 2. What about when x is 2? When x is 2, I have 2 cubed times 7. That is 56 plus 2. That gives you 58. And then change the x square remains the way it is. And then under the square root, what we have is u. And then the x, we change it to be du out of 21x squared. This x squared cancels this one. What is the constant here? Constant here is 1 over 21 taken outside the roots, outside the integral sign. I would have 1 out of 21. The integral from 2 to 58 of u raised to a half. This is u raised to a half. Then it is u. So we just need to integrate this and then insert our limits. So if I integrate this, I add 1 to the power, that's a half plus 1, and then divide by the new power. This new power is 3 out of 2. 3 out of 2. So what I have is u raised to 3 out of 2 times 2 out of 3, and that gives me 2u raised to 3 out of 2 over 3. Now multiply by this constant, which is 21 out of 21. And that gives you 2u raised to 3 out of 2 divided by 63. That's what you're seeing here. That's what you're seeing here. With our limits from 2 to 58. Then insert the limits. When you insert the limits, insert the upper limit here. It's here 58 raised to 3, square root of that. And then insert the lower limit, which is 2 raised to 3, square root of that, over 63. Use a calculator here and you get your answer in as 13 divided by 9, 3, 2, 9, and so on. Approximately this. Now, of course, you can leave your answer also as a fraction or inside form. There's no problem. And that's how we do integration by changing the limits.